Alright, with this one, we're going to take a look at 13.3, which is the quadratic equations. Sometimes we look to factor, all the time, factor, factor, factor. However, not all the time we can do it. Okay, sometimes it's blatantly obvious. Oh, I can factor this to a plus, x plus 2 and x minus 1. It doesn't work that way always, all right? Sometimes we just don't see it. Or it's just not possible. Everything can be reduced to simpler linear factors or the quadratic formula. Okay, that's just the way the system works, right? Well, when we solve equations that are trigonometric, we can take a look at them in terms of when we can factor and when we can't. This is one we can't factor. The factoring ones we did before. The ones we can't factor are the ones here. Right? So if I take a look, I have 3x squared minus 5x minus 4. We're going to use the quadratic formula. Again, remind yourselves of the coefficients a, b, and c. Make sure you take the sign in front of them because that's the big thing. So a is 3, b is negative 5, and c is negative 4. Plug it into our quadratic formula. Okay, negative b plus minus the square root of b squared minus 4ac all over 2a. Hopefully you've memorized that by now. Otherwise, I'm not a happy camper. All right, plugging it in, we get negative negative, which gives us 5. Negative 5 squared is 25, and 4 times 3 times negative 4 is going to be 12 times negative 4, which is negative 48, but it's minus, so it's plus 48. And then we get 5 plus minus the square root of 73 all over 6. A number where I say x is equal to. That would be the end of our standard problem. However, if we had the same problem and I replaced x with cosine of x, or cosine of theta, it works exactly the same way, except over here, I had x, it's just cosine theta, cosine theta, cosine theta, cosine theta, cosine theta. All right, this is where we get into a little bit more of a problem. All right, we're going to get nasty numbers. All right, a lot of times we need to know what those nasty numbers are. Over here, I actually computed this out. And over here, I computed it out. And you can see, after this point, we have to do the arc cosine of these angles. All right? Now, if we do the arc cosine of these angles, all right, we're going to get two possibilities. We're going to get a number or we're going to get an error. Okay? First of all, error is not an answer. It does not exist. Okay? Cosine of 2.25, it never happens. Remember, cosine is between negative 1 and 1, so that's why there's no value here. If we do the arc cosine of 0.590673, you're going to get 54 degrees. If you do negative, it's going to be a little different. You're actually going to get about, I would say, 126.3. It will actually produce an angle in quadrant 2 because our cosine lies in quadrants 1 and 2. All right, so it does give you an answer if you just put the negative in there. If you don't, you get the positive answer, which again becomes our reference angle. All right, if you use the one we have, it gives you a freebie, but you still got to find this number because it is our reference angle. All right, if you're in Q2 and Q3, reasons being, well, look, it's negative. One is cosine negative. Quadrants 2 and 3. All students take calculus. 1. Okay, 1 and 4 are positive, 2 and 3 are negative. So from there, we go on and we do 180 minus my reference angle, which is 126, which can be the freebie I told you, okay? And then 180 plus the angle, which is 234, okay? Pay attention to what they ask you to round to, all right? And you'll get your final solution set. Make sure you also list it out, okay? But you can see the similarities, okay? It's the same steps over and over. It's just this extra piece at the end, which we've done to every problem. It's the same thing over and over. So look back to your quadratics, and you're going to see if you can get to here, you just got one more step that we've been adding each time, okay?